now. The whole road is looking now. And at least you can see what I can see. Sometimes, yeah, it's going up really high. How small you are. I'm going home now.
So Felix had called me in the middle of the night, his time, 3:30 in the morning, basically asking me, Art, do you know who Joe Kittinger is? And I said, yeah, I know who Joe is. And he says, well, if you were going to break Joe Kittinger's record, how would you go about doing it? I said, well, it's 3:30 in the morning in Austria. You know, let me think about it. I'll give you a call tomorrow. My name's Art Thompson. I'm CEO of Cheshire Aerospace and also president of A to ZFX. So I proceeded to put together a 87-page document that basically laid out a detailed plan on the pressure suit using David Clark and balloons from Raven Aerostar, going through this path of building a pressurized capsule that we would design out and build here at Sage Cheshire, taking them up to altitude. We have two different groups. ZFX does the promotional vehicles, canned cars for Red Bull, all those canned cars you see driving around. We do special effects for the movie industry and also promotional vehicles and concept vehicles. Sage Cheshire, on the other hand, is more aerospace related. We do parts for many of the major aerospace companies and corporations, concept as well as production parts. And one of the things we're probably best known for is the Red Bull Stratos project, where we took Felix Baumgartner to 128,000 feet, making him the first person to free fall from a near space environment, going Mach speeds, breaking the speed of sound without the use of a vehicle. So from a concept, then we draw everything out in SolidWorks using HP workstations. Then when we're getting the suits, we're looking at trying to scan those images of the suits to get an accurate 3D model. So utilizing the Faro scanner, we're able to scan and create that image. Then by taking Geomagic solutions, we're able to wrap that and create a 3D model that we can put back into SolidWorks, do computational fluid dynamics, and then show that suit in free fall to do the calculations in advance before the jump to get an idea of what's going to happen to Felix in free fall. And I've seen a lot of different scanners and I've used a lot of different scanners and I've been disappointed by a lot of scanners of what I've seen. And when I saw the Faro, the simplicity in application, the use, the level of accuracy for what it is, it just makes so much sense. It's such a simplistic system and still collects a very highly accurate data point system. From that, we're able to wrap that into a model to be able to manipulate the data. It's important for us to be fluid with our design process, and if I have to worry about equipment, then we aren't thinking about what we're building. Faro really makes it so simple for us to go through that process because we can accurately collect data not only from a small object, but an entire room if we choose to. We were able to change the way people think about human physiology for high altitude egress. Private space organizations are looking at how to get people up into space. We're really looking with Red Bull Stratos and Sage Cheshire at how to get people down, looking at the safety systems and what's required. systems like Faro really help us to be able to utilize the tools to be able to do the analysis and testing of a lot of that data. Where we're going in the future is to utilize a lot of the tools that Faro has on hand, whether it's large scanning or small scanning to utilize for reverse engineering. Tools like Faro really help us to stay on top of that edge and be competitive and be above the fray. To be competitive in business, you have to be able to have the right tools, and Faro is definitely the right tool.